We are now approaching a circumstance for which NASA did not provide adequate preparation. The mysterious object we've named 3I Atlas, an interstellar visitor that we've been following closely for months, is now approaching a crossroads that might change our whole view of extrasolar visitation. The fact that we are going to disappear just as it is about to perform something remarkable adds another layer of unease to this already disturbing situation. The consequences of what is happening here go well beyond basic astronomical interest and into realms that test our basic notions of what is possible. So allow me to explain. Early this year, astronomers all over the globe rejoiced at a once-in-a-lifetime chance when 3I Atlas first came into our detection range. Here was our third verified extrasolar guest, an opportunity to investigate an extrasolar body using technology that was light years ahead of what was available during Oumuamua's excruciatingly brief 2017 journey. As it hurtles toward the sun at speeds of more than 200,000 kilometers per hour, we have been monitoring it with unmatched accuracy. Their peculiar deceleration patterns defy the laws of nature, and we have measured them. We have recorded its very unlikely path alignment with the ecliptic plane of our solar system, which would be geometrically positioned with less than 1% probability of arrival if it were really random. We have also examined its peculiar hollow interior structure, which contradicts the predictions of standard comet physics on the formation of natural entities by gravitational collapse. Up until this point, everything has followed the prescribed procedures and forecasts made by the scientific community. The date of 3I Atlas's perihelion, which occurs on October the 29th, 2025, is 7 days away. Its closest approach to the sun, according to mathematical calculations, is at 1.36 astronomical units. Just so you know, it puts it right in the middle of Mars's orbit, putting our space traveler under the intense gravitational pull and solar radiation of the red planet. We had been anxiously awaiting this crucial observational test for months. Such thermal attack usually elicits predictable responses from naturally occurring comets. Their catastrophic fragmentation occurs when mechanical stresses caused by temperature gradients exceed their structural integrity. Alternatively, stunning glowing tails can be observed as volatile materials sublimate explosively into space. In order to watch what happens during those critical hours, we have placed every instrument that is available across various continents and orbital platforms. However, things take a somewhat unsettling turn from here on out. We are about to enter a time of enforced blindness as 3I Atlas, as seen from Earth, swings behind the sun, entering the conjunction gap that astronomers had anticipated would endure for several crucial weeks. At the exact moment that this visitor has its most intense solar encounter, an observation shadow is cast by the geometry of our position in relation to the sun. When the viewing angles allow our telescopes to follow the area where it should come out on the other side, continuing along its predicted hyperbolic path, we will find out if it survived whole, shattered into scattered debris, or maybe it did maneuvers that make us question if we are witnessing natural phenomena, or something much deeper. A number of observatories are prepared. All eyes in the astronomical community are on the James Webb Space Telescope as they eagerly await the revelation of what is beyond the dazzling light of our star. Radar arrays on the ground will begin scanning for a returning signal as soon as the viewing geometry allows it, which is when solar conjunction finishes. In the anticipated trajectory zone, where 33 billion tons of stuff should be moving at accurately computed velocities, the advanced tracking systems of the European Space Agency will conduct a search. Furthermore, the looming mystery surrounding all observatories becomes impossible to ignore. What if it turns out to be empty? Because strict scientific technique requires us to do so, let's look at the conventional possibilities before we get to more fantastical theories. The debris from 3I Atlas's total fragmentation during perihelion passage may become too small and scattered to be detected. For naturally occurring cometary bodies, that outcome is still not out of the question. When one side of the Earth experiences extreme heat from the sun and the other side stays cold, massive thermal tensions are created. Mechanical forces generated by temperature gradients over a nucleus in motion can rip delicate structures to shreds, and these gradients can reach hundreds of degrees Celsius. This catastrophic process has been observed time and time again with traditional solar system comets, but here's what scientists around the world are worried about when it comes to using this theory to explain 3I Atlas. There is always observable debris left behind when comets break up. Debris clouds are seen to be spreading and slowly dispersing across millions of kilometers. As they gradually fade away, dust trails reflect sunlight and remain visible for weeks or months. The orbits of the individual pieces are slightly different, but they may still be followed for a long time. At interplanetary distances, the Hubble Space Telescope can detect objects smaller than a city block, but so far, no independent observatories have found anything after conducting thorough systematic searches of the mathematically predicted trajectory zone. There is absolutely nothing like a dust signature, an increasing debris field, or any kind of fragmentary leftovers moving along predicted routes. The second common theory refers to mistakes in calculating trajectories. Possibly there are undiscovered errors in our orbital calculations, and the object will emerge from perihelion on a very different trajectory from what computer models predicted, putting it outside of the present search zones totally. However, there is a strong mathematical barrier that this hypothesis must overcome. In the months leading up to perihelion, observatories keep a constant eye on 3I Atlas. Using a network of autonomous observatories spread all over the globe, we were able to determine its precise location, speed, and acceleration patterns. Relativity corrections for Einstein's general theory of relativity, the pressure of solar radiation on the coma, and gravitational perturbations from all of the major planets in our solar system were all factors in those trajectory calculations. Typically, even interplanetary distance ranges spanning hundreds of millions of kilometers, the error margins on these highly accurate forecasts are assessed in mere hundreds of kilometers, which is incredibly small by astronomical standards. Missing the object's emergence entirely would necessitate trajectory modifications that would be orders of magnitude greater than what any known random mechanism could generate in a normal physical process. Small, predictable deviations within usual uncertainty ranges are not being discussed here. Here we have the mathematical matchup for what happens when an object with the mass of a small mountain decides to use gravity to its advantage and change its orbital path so it goes around Jupiter instead of continuing on its predicted hyperbolic exit trajectory to the outer solar system, as every law of orbital mechanics says it should. For natural, celestial things to undergo such a degree of trajectory change, unseen forces must be at work, forces that hint at disturbing possibilities regarding what we could be seeing. Natural mechanisms do not produce that type of trajectory alteration. The third possibility is the one that Harvard astronomer Avi Loeb has been openly expressing concern about since he initially examined the deceleration patterns recorded by 3I atlases a few months ago. What if the impending absence isn't a mere coincidence? What if the 29th of October perihelion is indeed what some scientists were worried it would turn out to be? An ideal chance to intentionally alter our course, completely hidden from any orbital or ground-based observation by the intense electromagnetic radiation from the sun. Allow me to enlighten you with the physical explanations of what could happen during those secret hours. In orbital mechanics, there is a theory that goes against our common sense when it comes to understanding motion and energy. This principle is called the Oberth effect, after the pioneering German physicist Hermann Oberth. Applying thrust force at the bottom of a gravity well at the exact moment when your velocity is at its highest causes even small propellant efforts to drastically alter your eventual escape path. There is no better time than this to make drastic course changes while using up as little energy as possible. On October 29th at 11:47 UTC, we will reach perihelion, the mathematically determined closest approach to the sun. This marks the deepest point within the strongest gravity well that exists within billions of kilometers of any direction. This is the best moment in its whole voyage to deploy any active propulsion capabilities that may be buried within the hollow interior structure that we've described on 3I Atlas. If it has enough energy reserves to generate control thrust, that is when it should do it. Imagine the new possibilities. Applying a tiny delta V velocity change, maybe just a few hundred meters per second, exactly at perihelion passage, could completely alter an escape trajectory into an elliptical orbital path, turning what seemed like a transitory visitor into an eternal resident of our solar system. On the other hand, this move could reroute the object to predetermined strategic locations. The asteroid belt is one possible location, where it may rendezvous with bodies that are currently invisible to Earth's radar. maybe to the outer planets, where human interference with long-term systematic observations would be minimal. Either the timing is extremely suspect, or it is just another unlikely coincidence that adds to the already concerning statistics. During critical periods, when anything out of the norm could happen, our surveillance capabilities go black. This is because we are fully concealed by 1.4 million kilometers of flaming star plasma that radiates across all electromagnetic wavelengths. As if purposefully taking advantage of that imposed observational blind zone, we find out if the asteroid has disappeared when visibility geometry allows detection again, when orbital mechanics enable observation to resume. Now think carefully about what is known about 3I Atlas's recorded behavior prior to perihelion, because the pattern is starting to look more and more like deliberate planning than cosmic aimlessness controlled only by gravity. This extraterrestrial body approached our solar system in a highly unusual orientation, geometrically aligned with the ecliptic plane to within a mere 5 degrees of perfect coplanarity, an orientation that occurs in less than 2% of exceptionally random interstellar approaches. Between September 23rd and 26th, it steadily slowed from 68.2 to 67.9 kilometers per second, using methods that contradicted every known natural physical process involving stationary celestial bodies. This deceleration was observable and validated. Based on brightness analysis and gravitational influence calculations, its density measurements strongly indicated a hollow interior architecture. This design element is highly illogical for naturally accreted bodies created by random gravitational collapse, but it is a perfectly reasonable engineering choice for artificial artifacts that need to have minimal mass and maximum protected internal volume for sensitive components or cargo. In September, there was a direct coronal mass ejection event which should have shredded any loosely aggregated collection of ice particles and dust grains held together only by weak gravitational forces. However, this visitor managed to survive. After months of monitoring, its spin has remained stable, demonstrating an accuracy that celestial objects that fall to Earth due to random accretion processes can never hope to match. Its most statistically significant event occurred on October 3rd, when it seemed to perform a precision flyby of Mars, coming within 29 million kilometers at timing, a mathematically implausible event that, when all the geometry of the trajectory is taken into account, yields a random chance calculation of less than 1 in 50,000. It is theoretically possible to account for all of these recorded observations by using sufficiently novel applications of exotic but formally natural physics principles when considered separately. Maybe the Martian flyby date is explained by the fortunate geometric alignment, while the surprising resilience is explained by the odd chemical makeup. We may have experienced an entirely new sublimation mechanism in our scant encounters with extraterrestrials. However, when all of the data points are included in one comprehensive collection, they form an indisputable pattern. The emergence of patterns in natural systems is often a sign of the operation of fundamental organizational principles, either by physical principles that we completely understand or by intentional design, which we are just now starting to acknowledge as being feasible. In comparison to what we saw with the Muamua in 2017, what we may be seeing with this disappearance is radically different. The first confirmed interstellar visitor did, in fact, exhibit some enigmatic behavior during its brief stay. Conventional rocket equation physics would have predicted the observed thrust as a result of outgassing, but it accelerated abnormally away from the sun. Researchers like Avi Loeb, who were brave enough to openly offer such unsettling possibilities, speculated that its manufactured origins would be due to its abnormally high albedo surface reflectivity and extremely elongated shape. Oumuamua did, however, conform to gravitational mechanics by following a hyperbolic escape route. We were able to calculate its precise orbit and continue tracking it through observations until it became too far away and optically faint for even our most sensitive instruments to detect its reflected sunlight. It arrived from interstellar space and accelerated mysteriously but measurably. Part 3I. The next Atlas mission seems to be going against decades of astronomical norms and doing something totally new. It won't become gradually undetectable as distance naturally decreases apparent brightness if it follows the trend we're now seeing. In fact, it could disappear suddenly, just as Earth-based observers should be able to see it clearly after emerging from perihelion passage, hot and geologically active, and possibly displaying spectacular cometary features that would make it one of the brightest objects in the night sky in November and December. Mathematically anticipated empty space may instead greet us, forcing us to address concerns that cast doubt on the long-held assumptions that humanity has relied on in systematic observational astronomy. Since this institutional reaction to the evolving disappearance scenario is consistent with patterns of behavior we've observed with past extraterrestrial visitors, it merits close scrutiny. Public remarks released by NASA purposefully avoid taking a side or making a commitment, instead stressing the need of collecting and analyzing all available evidence before making any hasty judgments. Even though solar conjunction geometry creates a detection gap, the European Space Agency publicly states that the most likely explanation for any object not being redetectable after perihelion is full fragmentation and dispersal. Despite having the best possible viewing geometry from their Tianwen-1 Mars orbiter during the crucial October 3rd flyby, when 3I Atlas passed closest to the red planet, the Chinese space program is deliberately preventing the international scientific community from accessing detailed imagery analysis and spectroscopic data. Researchers who are familiar with past experiences with extraterrestrial visitors immediately notice the troubling historical precedent carried by this blatant lack of information. For months after Oumuamua's first detection, crucial spectroscopic measurements and high-resolution radar tracking data were classified or not released while the spacecraft passed through our solar system in 2017. With the arrival of Iborisoft in 2019, we saw institutions that were similarly sluggish to release extensive observational datasets to public archives and peer-reviewed journals. The international information pipeline has once again constricted, like a pressure valve being gradually closed against rising interest as 3I Atlas conducts what may become its permanent vanishing act during perihelion passage. Maybe there are no interesting explanations for these systemic delays. They may just be the result of ordinary bureaucratic processes. Government funding cuts leading to bureaucratic gridlock, uncertainties in instrument calibration necessitating further verification before publication, or even just careful institutional vetting procedures put in place for extraordinary claims before they can be released to the public, which could cause public panic and premature speculation. However, the cumulative pattern is becoming harder to explain away as random chance at work in seemingly unrelated occurrences. Official institutional channels go eerily silent whenever an extraterrestrial visitor poses a serious threat to our long-held beliefs regarding astronomical natural processes. Furthermore, the act of systematic silence becomes a signal in and of itself, a strangely intended message communicated through the blatant lack of information rather than open and honest communication. As a theoretical physicist who has spent decades exploring the universe's less obvious but no less intriguing possibilities, I don't see this as evidence of a paranoid conspiracy involving secretive planning. It stands for something that is more relatable and, in the end, easier to understand from a psychological perspective. There's institutional reluctance to face the truly unknown because of the inherent uncertainty in doing so. It's the administrative dread of public confusion going out of hand, of hasty assumptions making people uncomfortable or even embarrassed, and of publicly recognizing findings that don't conform to our current scientific theories and educational programs. However, as an intellectual endeavor, science will inevitably stagnate if we consistently let institutional fear dictate the bounds of permissible inquiry and research. Natural 3I Atlas fragmentation by standard thermal stress mechanisms should have resulted in the discovery of observable evidence of that catastrophic process. We are able to track and model dispersed debris fields, dust trail signatures, and fragment trajectories. We should have enough knowledge to computationally model the processes that cause the object's trajectory change, such as asymmetric outgassing or radiation pressure interactions, and anticipate with some degree of accuracy where the object redirected itself if these are exotic but ultimately natural physical processes. We have a deep philosophical and scientific responsibility to seek the truth openly and honestly, Regardless of how politically or intellectually controversial the consequences may be, if neither of the two mainstream explanations works and we are really facing something that operates beyond our present theoretical understanding, whether it's new physics we haven't found or technological artifacts we never seriously expected to encounter, if we want to know what happened during those obscure perihelion hours, we'll have to wait a few weeks. In order to determine whether the 3I Atlas redirected itself due to natural or intentional trajectory alterations, observatories all across the globe are methodically searching large areas. In order to carefully survey areas where debris could have been dispersed due to natural gravitational disturbances or fragmentation dispersion patterns, the James Webb Space Telescope has dedicated valuable observational time to this task. In order to determine the object's present location and velocity vector, ground-based radar arrays are methodically scanning through all conceivable positional coordinates and listening carefully for any reflected electromagnetic signal. When all other avenues have been exhausted and the 3I Atlas still hasn't been located, we'll have to face the realities that the majority of scientists have safely dismissed as science fiction rather than giving any serious thought to from an astronomical perspective. Is it possible for an object to consciously avoid electromagnetic detection across many wavelength bands? Is it possible that it will use stealth technology, unusual materials, or geometric arrangements to reduce reflectance signatures in the infrared to radio frequency range? Does it now occupy regions of space that we haven't even thought of searching for based on traditional gravitational mechanics? Could it have undertaken trajectory maneuvers so radically during perihelion passage? Could this absence actually represent what superficial observation suggests, the most philosophically uncomfortable possibility perhaps? We may have just witnessed something operating under organizational principles and physical capabilities we haven't begun to fully understand. It was an intentional departure, a calculated exit executed with precision timing during the brief window when comprehensive observation was temporarily impossible. We intentionally left behind only unanswered questions and the profound collective realization, regardless of whether 3I Atlas turns out to be entirely natural or a technological artifact. If it breaks apart catastrophically due to thermal assault or intentionally departs through controlled propulsion, it has already achieved something truly significant for human awareness. It systematically compelled us to broaden our scientific paradigm beyond the cozy certainty we've held since systematic astronomy started. Our cosmos is not bound in any way to obey our theoretical predictions or to fit neatly into the classification schemes we've drawn up for the sake of efficiency, as has been proved beyond a reasonable doubt. Moreover, and this is of utmost importance, it has served as a reminder that the act of meticulous observation is the most potent means by which humankind can increase its store of knowledge, regardless of how much we may have believed we understood about the underlying principles of reality.